Precalculus 6.1, we are looking at law of sines. And so right triangle trig when we're doing sine, cosine, tangent, and the other reciprocal functions we use to solve right triangles when there's a right angle. But we need methods to solve and find lengths of sides and missing angles when we don't have a right angle. And law of sines is one of those that we use, and law of cosines is another one, which we will do in the next lesson. So law of sines we'll use to solve when we have angle, angle, side, angle, and side, side, angle. And I don't know if you remember those from geometry. Let's do just kind of a quick review so we're not talking about triangles that have right angles. So there we have it. Angle, angle, side just means you have two angles of one triangle equal to two angles of the other, and one of the non-included sides congruent. So it goes angle, angle, side. And the angle, angle, side of one triangle is congruent to that angle, angle, side of another triangle. If we are looking at angle, side, angle, then we are talking about the side has to be between the angles. So I can start with these two angles equal, these two angles equal, but then it's the included side that is congruent. So it's a different setup. So this is angle, side, angle. Angle, side, angle. The side is included between the two angles. So when we see that setup, we're going to be using law of sines. And then side, side, angle, we'll see that when we get down to example 2. Side, side, angle, again, is just going to be that you have sides congruent, a side congruent, and then a non-included angle. So say these angles are congruent. So side, side, and then angle. Side, side, and then angle. So anyway, those are some of those setups. So here is the formula for law of sines, and it just says in a triangle with sides A, B, and C, the length of side A over the sine of A. Now notice that here's angle A, and it is the side opposite it that's little a. That always happens. Anyway, so A is to sine of A as B is to sine of B as C is to sine of C. And this is using standard labeling of a triangle. And standard labeling of a triangle, if we have angles A, B, and then C, the side opposite A is little a. The side opposite angle B is little b, and the side opposite angle C is little c. So when we set these triangles up, it is assuming that you're using a standard labeling of the triangle. And so if that is the case, and we have the right combinations of sides and angles, we can use law of sines. And when we don't, then we will be talking about law of cosines in the next lesson. So we have in example 1 for triangle ABC, we have A is 35 degrees, B is 50 degrees. So be careful on these. Be sure that you set your calculator to degrees. It's a change from the radian mode, and you're going to want to be careful with that. So when I set this up, I don't worry too much about the angles appearing to be the correct degrees. I'm going to do angle A. I put B up here this time and C down here, and that just means this is little a, this is little b, and this is little c. And so A is 35 degrees, B is 50 degrees. And then they said A is 16 feet. So you're going to be asked to solve the triangle. Find the remaining angles and sides. So what I'm going to always want is an answer box. So you will have 3 pieces of information. Here we have 2 angles and a side. And so you have 3 other things to find. So you need to find B, the measure of angle C, and C. And the book will round to 2 decimal places. When you get to calculus, AP Calculus goes to 3 decimal places. So round to 2. But only do that at the end. You're going to be using some of these values to get other values, and then you need to use more decimal places so you don't have rounding error. So at the end, round each answer to 2 decimal places. So right here, the way this is set up, I know this angle, I know this angle, and I know this side. So this is an angle, side setup. And so we will be using law of sines. And what you want to do is, let me get rid of the A right there. I'm just going to write 16 feet. You want to look for where you have a side and you know the angle opposite it. So I have 35 degrees, I have 16 feet. I'm going to use that in the law of sines. And it's going to be 16 is to the sine of 35 degrees. And then you just have to let the information drive you as to what you're going to use next. I have angle B. I know its value, so I'm going to find B by using B is to the sine of 50 degrees. So again, we are always using the side opposite of the angle in the ratio. So just here we had 16 feet, and that was the length of the side opposite the 35 degrees. And now I am trying to find B, and the angle opposite of that is angle B of 50 degrees. So we're working with the side opposite in the angle in the ratios. So 16 is to sine 35 as B is to sine of 50. Now we're just going to solve. And so to solve this, multiply both sides by sine 50, and I'm going to get 16 sine of 50 degrees is to sine of 35 degrees, and that will be B. I just multiplied both sides by sine 50. And then put that in your calculator just like that. So we'll pull up, make sure your calculator is in degrees. Oops. And so if I tap on that would be radians, I need to make sure I'm in degrees. And then I want that 16 sine 50. And that's going to be divided by sine 35. And so that 21.3689, you need to write those values down, go to 5 decimal places, because this isn't my final answer. And I'm going to get B to be 21.36892. In my answer box, I will just write 21.37, and that is going to be feet. But I'll probably be using B to find something else, or I could, so I want to make sure I have more decimals in case I use it again. All right, so that's B. And then I'm going to also need to set up to find C. Well, the measure of angle C, since you know 2 angles already, is just going to be 180 degrees minus the 35 degrees minus the 50 degrees. And so you can get an exact value for angle C, and it is 95 degrees. So now I know this is 95 degrees, and that's an exact value. And now I need to find little c. So I would encourage you to use the information that was given to you when possible rather than the ones that you've created, such as you got the value for B. I would stick with 16 to sine of 35 since that was given information, and use that to help me find C. And it'll be as C is to the sine of 95 degrees. So again, multiply by sine 95. I'm going to get 16 sine 95 degrees all over sine of 35 degrees. And that's going to be C. And so we're going to approximate C. So let's go over here and evaluate. And we have 16. Oops. Sine 95 divided by sine 35. And there you have the value of C. So 27.78900. And so that's going to be 27.79 feet. And there you have your answer box. And in this one, we didn't end up having to use B to find C, but we will in the next, or something similar to that. And so you want to always have extra decimal places available in case you end up having to use that value. All right, let's go ahead and look at example 2. So again, we're going to start, here's what I'm trying, I'll put A here, B here, C here. I just changed it up a little bit, but that means this is A, this is B, this is C. Just that idea of the sides opposite the angle, we'll get that lowercase letter. Now we have that A is 40 degrees, and the length of A is 20 meters. And then the length of B is 12 meters. So this is one of those side-side angle cases. The angle is not between the two sides. This is the angle between the two sides. If that C would have been 40 degrees, I'd have a side angle side set up, but I don't. So we are going to go about solving this. And I'm going to need an answer box. I'm going to just put it down here. And so you have 3 pieces, 2 sides and an angle, so you're going to need the 2 angles and then that missing side. So all your final answers need to be in that final box. And then organize your work so you can follow it. So we've got 20 is to the sine of 40 degrees. And so I'm going to work with B first because I have the side opposite it. So as 12 is to the sine of B. If I cross multiply, I have a 20 sine B equals a 12 sine 40 degrees, which means solving for B, sine of B is 12 sine 40 degrees all over 20. And then to find the measure of angle B, we are going to take the inverse sine. And instead of writing out decimals for that, let's just put that exact value in there. And we're going to get the inverse sine of that. And so now I want to go see if I can find that inverse sine in Desmos. All right, so see if we can do function. There we have it, inverse sine of, and then main 12 sine 40 divided by 20. And so you can just put it in just like that, and you don't have to carry over the decimal places on it. And we have that 22.68. I'm going to go to 5 decimal places because in this one it is going to matter in terms of we're going to have to use this value to get some other things. All right, then to find the measure of angle C, now that we know 2 angles, we can find the measure of angle C, but it is approximate by taking 180 degrees minus the 40 degrees and minus this 22.68550 degrees. And if you work that out, you're going to get 117.31450 degrees. And then I'm going to use that 117 degrees to find the length of side C. I'll move this over a little bit. And so now that I know C, I can set up, again, 20 is to the sine of 40 degrees, as C is to sine of the measure of angle C, which is the 117.31450. On this one, if you don't use enough decimal places in that angle, you could have rounding error when you go to 2 decimal places, and you would lose points for that. So you want extra decimal places when you're using this to get another value. So in this case, just multiply both sides by the sine of that 117 degrees, and that will get you C. So C will be 20 times the sine of 117.31450 all over the sine of 40 degrees. And then plug that in to your calculator. So if we come back over here, enter, and then I'm going to go 20 sine of 117.31450, and then divide it by sine of 40. And there we have it. So that's going to be that 27.64525. And I just want to come up here and just see as I delete that, would this change to 2 decimal places? So if I don't use enough decimal places, notice how that number is changing. So far it's working for us, but it might not. Notice if you only had 117, it wouldn't be the same answer. And that's why you don't want to round those. You want to use extra decimal places. And it just varies how many extra you need, but if you use 5, you're going to be okay. So then fill in your answer box, and they will be giving you to 2 decimals in the back of the book, so 22.69 degrees. And angle C, 117.31, and you need the degree symbol on those. And then the length of that side, C, is 27.65, and those are meters. So that's solving with that law of sines. Then we have a new formula for area of a triangle. We've had area of a triangle is 1/2 the base times the height. And so if I'm going to start with that. And in this case, it would, for this triangle right here, the area would be 1/2, well, its base is C, and its height is called H. So they're letting this whole side length be C. And that would be how we'd find it. But there's another formula that comes in super handy, and it has to do with taking this triangle right here and finding the height of it using B and H and angle A. And we're using right triangle trig because that is a right triangle. We've got this right angle in here. And what we set up is that the sine of angle A is the opposite leg over the hypotenuse. And then we multiply both sides by B. And that's a new expression that I can use for the height. So there is my height. So in this area, the old formula, we take 1/2, and the base of this triangle right now is C. So for this whole triangle, I'm finding the area of this whole triangle. The base is C. So in for base, I'm going to put C. But then for in for height, we're going to use this new expression for height. So in for that height, we're going to instead use B sine of angle A. And what that does is it allows me to find the area. Well, let's look at this a little bit. Here's angle A, so I know this angle. And if I know this side and I know this side, I can get the area of this triangle using this formula. And what happens is as long as I have the two side lengths and the angle that is created by those sides. So this side and this side create this angle where those two sides intersect at that vertex. If you know that angle and the lengths of those two sides, I can find the area of this triangle by taking 1/2 the product of those two legs times the sine of the included angle. Now, they come down here in this box and they give you 3 different formulas. But it's just a matter of if I know that this angle is 110 degrees and this is 8 and this is 5, it's important that those two sides that create that angle, this is the included angle, the area of this is going to be 1/2 of 5 times, 8 times the sine of 110 degrees. And I don't need, it doesn't have to be a right angle to do that. All right, so here's an example for that. Example 3, find the area of a triangular lot containing side lengths that measure 84 and 55 and form an angle of 115. So you have 115 degrees. So there's my beautiful triangular lot. And those two sides create, and obviously I don't draw to scale. I put the 84 on the shorter side, but it doesn't matter. It's the idea is that they both intersect right there, and that 115 degrees is created by those two sides. So we're set up perfectly to find the area of this. Area is going to be 1/2 the product of those two sides that include the angle that we're going to take the sine of. And again, make sure your calculator is in degrees for that because they gave you the angle in degrees. And if you put that into your calculator and work it out to 2 decimal places, comes to 2093.57. And area is always square units. So you need square units for that area. That's it.